opinion, and let me start out with something that doesn't seem related. I'm going to write down 4 squared here equals 16. All right, now notice here what I'm going to do is just write down all the divisors of 16. All the divisors of 16. So I'll just do it in a columnar fashion, 1 over 16. 1 times 16 is equal to 16. What's the next one? 2 times 8. 2 times 8. All right, and then let's copy 4 down twice, just for emphasis here. 4 times 4 is 16, and that's the divisors, right? But notice there are 5 divisors, okay? So there's 5 divisors. Now, y'all, you can see this process would happen for any perfect square. Okay, any perfect square, this kind of process would happen. And in fact, perfect squares are the only natural numbers that have an odd number of divisors. That's a fairly well-known fact, and that's what we're going to end up using. So let me write down the standard result. This isn't a rigorous proof, but hopefully convincing. K squared, where k is a natural number, has an odd number of divisors. Number of divisors. Allow me to abbreviate since I write slow. Number of divisors. Actually, I write pretty fast. It's just this interface. I'm still having a little bit of trouble with it. Okay, now let's go down and see how that's going to help us out here with what is referred to as a binomial coefficient. You guys have seen these things. They're in the binomial expansion. Pascal. They're how you get the rows of Pascal's triangle. They're combinatorics related. But anyway, we're not worried about that right now. Now let's rewrite that. Let's rewrite this in a way where the above result might be useful. So I'm going to write this. 50 is 2 times 5 squared. Okay, so I'll write 2 dot 5 squared. Okay, 49, of course, is 7 squared. Okay, and then we got times 48. Okay, now y'all, this 3 factorial is just part of the binomial coefficient formula. 3 factorial is 6. I'll write it right underneath the 48 there. Okay, and so you can see right here, we end up with 2 times 5 squared. 2 times 5 squared times 7 squared all over 8. And I didn't do much on that step except divide 6 into 48. So we get times 8 right there. Y'all, but notice this is equal to 2 cubed. And so on the very next line, well, I'll just write the thing out, folks. I think nobody wants to see all the boring arithmetic here. You would have 2 squared times 5 times 7, all quantity squared. But hey, that's equal to a k squared, right? And so we never had to find the Hindu-Arabic expansion. That is a k squared. And so that means odd number of divisors. Odd number of divisors without ever knowing how that binomial coefficient looks or smells. Odd number of divisors. I thought it was kind of cool. All right, so that completes the proof. I hope you thought that was as neat as me. And let me just get this circled. Okay, folks. And again, I think it's kind of a neat, if you can do something to ease your computations right here. The whole trick here was just to not have to actually calculate this number and prove that it had an odd number of divisors. And we managed to do that. Hope you enjoyed.